Hello, everyone. My name is Andrew Slivker. I'm Chief Technology Officer from Nevatech, and my presentation is about the state of the art of API management for API designers and developers. First of all, a couple of words about myself and the company I represent. Nevatech is Atlanta, Georgia, United States-based company. It's a software vendor that operates exclusively in the area of API management and governance. So we offer our product Sentinel since 2011 with customers around the world, those who are leveraging uh, APIs and APIs integration solutions in conjunction with API management infrastructure and tools. So today I'm going to be talking about few aspects of API management that help improve productivity of API developers and designers. And I'm going to give just few, very specific aspects that, based on our experience and experience of our customers working with APIs and our API management product, proved to be invaluable and effective means to provide, effective API designer and API development experience. So, and literally, it's going to be just very few, items that I'll be covering in this short presentation. So first, we'll start with API catalog structure. It is not unusual. In fact, it's very typical, I would say, to see API catalogs organized as a list of flat collection of APIs. On this screenshot, you see a list of APIs organized as a flat list in a collection. And again, it doesn't matter where this screenshot is coming from. Most of API management products organize APIs in a flat list. What's really important is that typically APIs are internally organized in some logical groupings. And that's why it makes sense, and it is done in the Sentinel API management product, organized as a hierarchical list of folders. Now, what does it mean, hierarchical list of folders, and why does it help to better organize your APIs within the API catalog? The analogy can be very simple. Imagine you have files on your laptop or computer. We're all known for many, many decades, probably from the first days of inventing operating systems, whatever this operating system is, that files are organized by folders. And that is simply because it's the very efficient and convenient way to organize assets, computer assets in the form of files, according to some particular logic. Very similar concept with API catalogs. Yes, you have APIs. They are your software assets, and you can organize them hierarchically spread over different folders and subfolders, where each folder and subfolder may represent a particular project, a particular solution, a business partner, actually anything that makes sense for organizing APIs together. So the difference between flat list of APIs and hierarchical organization of folders ultimately creates a number of very significant improvements to the process and effectiveness of building and managing APIs in any API integrated solution. So what are these benefits when it comes to hierarchical folders? Well, the first one, obviously, your APIs are structurally organized by some, logical groupings, whatever they are. And you can have as many levels of depth for the organization of the logical groupings. Another one, you can have controlled and secure access to those groups of logically connected or linked to each other APIs. And I'm not talking about security of accessing APIs at runtime when messages are coming through the systems. I'm talking about security of accessing API catalog, effectively API management portal or administrative console, if you wish, by API management users. So you can have multiple groups of developers and designers working with large number of APIs within your organization, or maybe APIs that you consume from your partner organization. And you can organize them by folders, and different development groups, operations groups, infrastructure engineering groups can have different access to different segments or subfolders of the folders and subfolders of the hierarchical structure. So secure and managed controlled access to the repository, to the API catalog itself, is what hierarchical structure also provides you with. Now, another interesting aspect is that you can include any other artifacts typically associated with APIs and API management also in the folders, like managed security policy templates, access control rules, maybe service level agreements that you define for your APIs that will be effectively kicked off during runtime. Even the API management users themselves, as I mentioned earlier, can be also placed in different folders, limiting their access and visibility into the entire API catalog. Finally, with the hierarchical structure of API management organization of APIs within API management infrastructure, you can get better monitoring analytics visibility, because you can navigate to a particular folder and look at the monitoring of all the APIs just within the scope within that particular folder. Same thing with analytics. So instead of looking at a particular API, which you can always do, or maybe all APIs across the entire catalog, you can also have very fast and very efficient access to analytical real-time chart and logs immediately at the particular level of grouping identified by a folder in the hierarchy. So that was the first feature that I wanted to talk about. So when you deal with API management vendors, you can and probably should expect a bit more advanced structure of API catalog in order to be more effective during your design time and runtime management of APIs. The next feature I wanted to talk about, which I call Backend APIs as API catalogs first-class citizens. For that, let me give you the definition. What does it mean, a first-class citizen? And before I give definition, let me explain how typical process of creating gateway API looks like in the majority of API management products. Again, I'm giving a screenshot of some, API management infrastructure that has, as I mentioned earlier, a flat list of APIs. And as part of registering your API that effectively will be hosted on API gateway, you, behind the configuration and as part of the process of configuring that API, you will be given address in the API gateway, but you will have to assign yourself address and ultimately security policies of the backend API. So what you have here is that backend APIs are configured behind and as part of the process of configuring the gateway API. There is no configuration of the backend API by itself. It's always buried behind configuration of the actual gateway API. In a first-class citizen scenario, you register backend APIs literally as an API independently from any gateway APIs. So in case of our product, Sentinel API Management, you can see the same hierarchical structure that I talked about earlier on the left side, You can see some, physical API, that is actually your backend API, but it is registered entirely in the API catalog, in the API repository, as a standalone, API, which has complete definition that you can navigate through. You can look at the schemas, and you can extract Swagger and Open API specifications for this backend API. So important part is that your backend APIs are registered side by side independently in the same API catalog with API gateways. What are the benefits that affect effectiveness of leveraging API management infrastructure for your APIs when backend APIs are treated as independent first-class citizens? First benefit is that you can register all your backend APIs in API catalog regardless whether they are managed by API gateway or not. In the previous case, there is no, your backend APIs are always associated with the gateway. There is no configuration of the backend if there is no API gateway. In this scenario, when they are first-class citizens, they're independently registered, and you can have them registered even without API gateways, which gives the value by itself, because not necessarily you might have all APIs in your system, in your integration solution, necessarily managed by API gateways. There might be some potentially that are not managed by API management, and yet they're registered in API catalog, which becomes your central knowledge base to learn about everything what you have as far as it goes for your APIs. And that's tremendous value by itself that can be leveraged with this type of infrastructures. Secondly, you have Swagger and Open API metadata generated for your backend APIs by the catalog. It can be uploaded or it's generated, on the fly, separately from your gateway APIs. Why is it important that they are independent? Because they can be different. Typically, again, in a typical API management, solution, or infrastructure, you have Swagger only for the API gateway. And that's understandable because, this is the Swagger that will be given to API client applications. But nevertheless, you developed your APIs as backend APIs, you deployed them, and you want to know what actually they do, what Swagger they expose, regardless of the fact that there may be a different Swagger exposed by the gateways. And that Swagger exposed by the gateway, it really can be different because it is not unusual that your gateway requires and adds maybe some query parameters or headers, or something injects in the schema, modifies schema of the objects once your backend API exposed to the outside. So your messages can be enriched, changed, transformed on the fly by the gateway. Swaggers can be different. It's important to know each of them independently. The next benefit, you can easily manage many-to-many relationship between your backend API and gateway APIs. As you've seen in the previous slide, when you have one-to-one relationship between gateway API and backend API, if you need the same backend API to expose with another new virtual API or gateway API, you basically create this new gateway API, and you again configure it with the same address of the same backend API. So the relationship is one-to-one, right? In case of independently first-class citizens scenario, you register your backend API once, and then you have as many as you want virtual APIs or gateway APIs referencing, linking, connecting to the same backend API on the backend. That helps to manage that relationship and understand effectively what's the dependency impact, how your backend API depends on multiple, exposed through multiple virtual APIs. If you need to, and impact implications are also different, because if your backend API changes, let's say address changes of the backend API, you change it in the registration of the backend API, and all the gateway APIs automatically learn about that change and automatically reconfigure themselves. If backend API is not first-class citizen, if it's registered behind the virtual API or gateway API, then every time the backend API address changes, you have to go and change each and every virtual API, and you have to find them first and then change them. Moreover, we will see a bit later that it's not just many-to-one relationship, it's many-to-many. So just like you can have multiple virtual APIs referencing the same backend, there might be cases when you have one virtual API that aggregates multiple backend APIs. Finally, as I've mentioned, you can easily track dependencies. These dependencies can be easily exposed immediately through the user interface on your API management console, through dependency diagrams, through dependency trees, and so on. So it's tremendous value in terms of applying impact analysis. I mentioned aggregation, many-to-many relationship. That's another invaluable capability that can be expected and should be expected from API management infrastructure. On this diagram, I can actually showing a screenshot from Sentinel API management where it shows design surface of some gateway API that virtualizes or effectively forwards messages to 3 different backend APIs. So you can, through simple drag and drop from the repository on this surface, you can create in a matter of half a second this very visual diagram that shows that you can aggregate multiple microservices into a single aggregated API exposed through a single endpoint on the gateway. And that's the capability that represents many-to-many relationship finally, when a single virtual service references multiple backend APIs. Finally, I'd like to talk about yet another interesting capabilities that is called Mockup APIs. This is the capability that should be expected again from API management infrastructure when you can leverage API gateway as in a scenario when it does not forward messages to the backend managed APIs, and instead it automatically configured to generate mockup responses. So this mockup API's capability built in automatically into the API gateways gives again tremendous advantages and benefits to API developers and designers. What are the benefits? First of all, you can start development of your API client applications even before backend API is ready. Remember, you have the registered backend APIs in your repository. That registration doesn't necessarily mean that your physical backend API exists, or if it's actively hosted and it's up and running. It's just registered there. And as soon as it's registered, you can create a gateway API, virtual API, that configured to forward messages. But then there is a tweak on the user interface when you can say that do not forward these messages. I know how to expect the messages by the gateway, but the gateway instructed not to forward them to the backend, but instead send the mockups back to the client. That gives an opportunity to start developing client applications even before the backend is ready. And you can test your client application communication and interaction with the API gateway ahead of time, even before the backend is ready. Another benefit, you can test your API client for successes and errors handling ahead of time. Again, the errors and successes are coming from gateway ultimately. Excuse me. Even if backend APIs are not are not accepting in real-time messages, but instead mock-up messages are sent through. So you can test this part. Finally, not finally, more importantly, you can test and debug security between client and gateway ahead of time. Excuse me. Ultimately, your client applications will be accessing gateways, and testing that security, which really API client applications are concerned about ahead of time, is an important thing, and it saves time during design and development stage. I'm skipping question and answers, session because this is recorded video. So thank you very much. That's a very short presentation on few important capabilities that should be expected and can be expected from sophisticated API management infrastructure to improve your effectiveness during design and development stages. Thank you.